Okay, so web services might mean one of two things. No? uh, a service provided by one electronic device to another electronic device that communicates via the World Wide Web, or a server that runs on a computer device that serves web content by listening for requests on a certain port over a network. We have HTML. I don't know if you're familiar with JSON, no? Yung JSON, XML, and images, no? In a web server service, no, machine readable file formats such as XML and JSON are transferred via web technologies such as the HTTP or the HTTPS, no? The hypertext transfer protocol or the hypertext transfer protocol secure. So in reality, a web service is typically used to provide an object-oriented web-based interface to a database server, which may then be used by another web server or a mobile app to provide a user interface to the end user. And many businesses that give data in HTML format will also provide it as XML or JSON on their server, of course, open through a web service to allow syndication such as Wikipedia's exports. No, a mashup is a web application in which a web server consumes many web services from separate machines and compiles the content into a single user interface. And to give us more details about the topic, let us all welcome our second presenter. Go ahead, sir.
Thank you so much, sir, for that wonderful introduction. Just as what Dr. Marmelo has said in the earlier topic, think of internet as the packet forwarding mechanism. And with that in mind, perhaps we will have some ideas of what we could build on top of the internet. And my topic is all about web services. I'll be going over some of the key terminologies in here, such as request and response, the message exchange format, such as XML and JSON, just like what our professor has said. Service definition, we also have transport, such as HTTP, or today we have the secure HTTPS already, and in the past we have MQ. Now, to give you a simple definition of web service, we can simply say service delivered over the web. However, if we will look at the platforms that we are currently using today, one might ask, are these web services? Now, to simply look at the basic business model that we have, we look at the web, and below the web are, of course, is the business logic. And inside that, of course, we have the data. And one might say, for example, you'd like to build a web service with the use of the current web structure and business structure. It would be costly, it would be problematic if one would not be able to qualify the system as a web service. Having said that, for example, in a business model, if we create, for example, using the business logic, we could create a Java application, for example, or a Java a jar file, for example, with the use of the data. And then let's say a business data or data is transported over the internet, which will be utilized by other services, or let's say other platforms. It would be difficult. For example, there would be an update to the current business logic of an existing system. Having said that, we are looking at application interaction, just like what Dr. Marmelo has said earlier. It's in between these computers that communication happen. So if this is your app, an application should seamlessly cooperate and communicate and get the necessary data depending on what they need. Now, so a web service is a software system designed to support interoperability or machine-to-machine interaction over the network. So there are three, I guess. It has to be machine-to-machine. Three criteria for it to be a web service. It has to be interoperable, and it should allow communication over the network. Here are some of the definition of the web service based on Lano or Lano's book. Now for IBM, it says web service are self-contained modular application. Modular meaning it could be it's independent in itself and it's invoked over a network. Now, web services could be local, distributed, or web-based. Much like, more like, of course, the APIs that we have today. So today, for example, we would want to design a system where we would like to feed data over another application. For example, a traffic feed. We would like to design a traffic feed so that users of Grab or Waze PH would have an accurate feedback of the current status of traffic. And therefore, it has to be invoked over a network on a real-time basis. Today, WebSocket is one popular application or one popular WebSocket is the one popular intervention for us to get the real-time data from a specific platform. So now, having said that, technically, we could think of a service that we could provide over the internet, making sure that we have the proper communication to the data provider that we will be getting. And I'll be talking about that in the next slides. While Microsoft says, here's their definition, web service is a unit of application logic providing data and service to other application. Well, Sun says it's services on demand. Now, a smart web service is a web service that can understand situational context and share that context with the other services. So it's a clear definition that these are the situational context we could provide and share with other services. So if it's my server versus your service, they would understand the situational context. It produces dynamic results based on who, what, when, where, why the service is called. While HP says e-services are assets. So information, business process, computing resources, and application made available via the internet. So in Sir Alan's report, it was about the internet. And I've seen where JavaScript is more like understood in the past that it's just the front end, and today JavaScript has now its own implementation for the back end, and the language alone, for example, the web language is already in itself a robust system structure to deliver web services. Now, let's talk about the how. Now, how services are available over the internet. So it's just as simple as making requests to the internet. We are all familiar with this. There is a service provider who develops, implements the application or web service over the net and makes it available for the internet. Of course, the client or the application makes the requests and the server provider provides the response. However, we would want the term interoperability, where your web service can communicate to different types of application, independent to how they are structured, or independent to the language the language used in the structure, like a .NET application, a PHP application, or a Java application. So having said that, the request and the response should have a proper medium in which we'll be talking about the format, the use of the XML and the JSON the JSON format as the format or over the medium of the HTTPS protocol. A simple screenshot of an XML is this one, and the JSON file, perhaps you are familiar on how we specifically identify all the elements we would want to put into our JSON. If you are developing systems over the jQuery language or the Node.js, you'll be familiar, of course, you are familiar with what packages or installations are part of. Now, it's the same goes with the details you are providing over the internet with the use of the JSON or the XML. But the question is, how does an application know the format of request and the response? So in this example, we would want to ask, how did the application and how did the web service understood what was the request and the structure of the request, or how should the web service respond? And the answer is, it is through the service definition. Now, the service definition identifies the request and the response format. These are all in form of course, the documentation. The request structure is there, and of course, the response structure is inside the service definition and the endpoint. Now, the endpoint is where we use we utilize or the utilities of HTTP, such as post, get, fetch data are all in. Here are some examples of web service or web services. We're all familiar with PayPal, and PayPal enables application to handle online credit card payments in a secure and efficient manner. In the past, of course, we could not handle this kind of transaction because there is security involved, and there are liquidity protocols that, for example, a bank must adhere to before getting authentication. Yes, you could spend your money into that store, or however, with PayPal and PayPal as a web service, it was all made possible. Merchant support services as well, going directly, such as Amazon. We're familiar with Alibaba. In here we have Lazada, Shopee, and more. And it's a quick and fast moving environment of web services protocol. Now, here is a web service architecture. So it's as basic as a web service client over to the right. Web service provided by a site. So it's usually listed in some publicly accessible directory, so that potential clients of the service can identify if a service meets the requirements that are available. So yeah, this is the diagram for that. Now, on the other hand, the Java 2 platform the Enterprise Edition is a collection of the Java technologies. So we are familiar with already. We've been talking about the servlets, the JSP. Here are some of the examples: the Enterprise Java Beans. We have JDBC. We also have Java Message Service. So it's an API to communicate with message-oriented middleware. We have the Java Naming and Directory Interface, or JNDI, and Java Mail. All are in an Enterprise Edition to provide such framework. Now, here is a figure that shows a typical structure of the J2EE system. We'll be looking at the 5-tier architecture. So we have the client tier. This has, over the client tier, we have its responsibility is to display the information to the user and receive information from the user and transmit it to the presentation tier. So having said that, it may either be a thin client or with minimal processing apart from its visual interface functionality. So we also have the business tier, integration tier. The business tier, by the way, it contains the business rules of the application, and we will see the A, J, B in here, and we'll be talking about that in the next slides. Now, the business tier again, contains the business rule. For example, rules concerning what customers can be accepted for an online bank system. If for example, we're talking about PayPal, the business tier pertains to the qualities and the requirements, and of course, the authentication the system would give such user. Now, the integration tier, on the other hand, it's insulates the business tier and the higher tier from direct knowledge of how the data is stored and retrieved. So the integration tier is more like a system which bridges the business tier and the resource tier. And of course, the resource tier is the one who writes and updates data over the database, and which later on interacts with the business tier going out to the external web services. We also have the enterprise Java beans, or EJB. This is the one we saw inside the business tier. Now, session bean, or a business component dedicated to a single client or user that lives on used to model stateful or stateless interaction. So interaction, and there are stateful and stateless interaction. While an entity being a coarse-grained business component which provides an object view of the persistent data, so which is long-lived. So this is where we look at the stateless and the stateful session. Meaning sessions could either be could either store some client-specific state, so or stateless. Stateful session are a more general version of the HTTP session. So it's clear that it's used in the same way to record client information through a session to control access to the resource. But the general role is much wider and can encompass any client's session-specific business process. Now, on the other hand, stateless session beans provide service by a single method call. This include utility functions or logging services or invocation of a remote web service. So that's the difference. Now, sending an email, for example, to confirm that a client request has been received could be an example of a task carried out by such component. So there are some uses of entity beans, and it could encapsulate checks and business rules on data, which requires access to persistent data. It can also provide object-oriented interface to one or more relational database table, and components in business tier patterns such as observer. Here is a graph or a diagram where associated with any enterprise bean are several interfaces. We could see classes and their associations to the methods. So if two different EJBs or entity beans are related by an explicit association in the class diagram, now then the bean that is the destination of the navigation along this association must have a local interface, since the persistent data is accessed by the two beans. But anyway, this is just one, I would say, that at the time of the writing is one implementation of how enterprise bean are used and implemented. Moreover, the property system can be implemented in the J2EE framework by creating entity beans for property and the user, which mediate between presentation tier and servlets and the helper classes. The helper classes, by the way, it says in this figure, property is responsible for maintaining all the data constraint of this entity. Now, in particular, the service side checks for create property and edit property are carried out in the class. So I think this would pertain to banking or similar to the previous examples. Now, development process for J2E application. So yeah, we've talked about the business tier already. the presentation tier, and the database interface. We're done with this. For summary, the J2E provides sophisticated environment for distributed and internet system construction and for the definition of web services. So next would be the .NET. So the .NET is an important contrast to the J2EE, according to Lano, which is oriented to use Java for everything approach. Now, the .NET acts as a layer between applications and the operating system. It's interesting that the word operating system is mentioned simply because it provides a set of class libraries in which it's, of course, the .NET framework. Analogous to Java or C++, foundation class libraries and the ADO.NET Database Access API. So it provides specific support for web services construction using the SOAP, message exchange mechanism via HTTP. Now, the .NET has the advantage of supporting multiple languages on an equal basis, and it should have, of course, a performance advantage over the J2EE for Windows deployment, since it's optimized for Windows OS. So, yeah. Now, the .NET has the advantage of supporting multiple languages and on equal basis, and it should have performance advantage over J2 for Windows. So, here is an operating system application diagram where .NET provides us with how web services are communicated through the .NET framework. Now, to communicate with web services, one might opt in with the use of the raw HTML. It says here the most basic way a client program can extract data from a server website is downloading its pages. If you have tried parsing data from a website, for example, with the use of WebSocket, or in jQuery, we have Cheerio. Cheerio is a package development where one can parse data. But of course, WebSocket is better because it could provide real-time data, and perhaps you might be able to use something with that data with the use of WebSocket. For example, you're a data service provider where you're getting prices from different sort of exchanges for a specific stock price. A raw HTML, for example, with no, we cannot use raw HTML because it would not be. It depends on the server deploying the raw HTML if the data is live. However, for example, we could get the data straight from the exchange and gather all same prices and perhaps do a function where it would compute for a weighted average or weighted mean price for accuracy. And that is an example of a data service provider for specific stock price. Or if you're familiar with blockchain, in blockchain, the price of Bitcoin pertains to the volume of the buy and the sell, and the midpoint where the highest ask and the highest bid meets and dictates the price. So that's why it's volatile. But anyway, it's the same with how web services could somehow use data and come up with a specific web service. So a CSV could also be used or comma separated values. This is I think in the past. And now we are dependent and very familiar with the use of the JSON. And this one is an example from Lana's book, and perhaps this is from the yahoo.co.uk finance site. So this is an example of how house data could be. We can also communicate with the use of the FTP, or the file transfer protocol. And as we are all familiar with the FTP, we have the file, and then we communicate to the server, or specific clients has access to specific resource based on the level of authentication that they have. For example, someone pays for a premium of a Netflix service, or there are certain tier where people could have access to a specific file. SOAP, on the other hand, is, I think, the first web service group implementation of, of protocol for application to application communication. So I highlighted two of these, which are SOAP, which means now it's just called SOAP, Simple Object Access Protocol, where it uses the medium HTTP and uses the format XML or the XML files. While the one we are all familiar of today is the use of REST, or the RESTful. We're making RESTful APIs nowadays. And the medium would be, of course, the HTTP, HTTPS, and it utilizes everything that is offered by the HTTPS protocol, which are post, get, put, delete, and more. The format is very flexible. It could be an HTML, a JSON, or even an XML file, but JSON is the most popular one. In the SOAP environment, it's like this. There's an envelope, and there's a header, and the SOAP body are all the information. The part of request are inside the SOAP environment body. So all the XML encodings for most data types and parameters of the data are all inside this structure. So if the request is XML, of course, the response of the web service is XML if you're using the SOAP environment. Okay, so this is an example of how a SOAP, so there's a header, there's nothing into the header, but there are contents into the body, and these are understood by machine, or the server understood that these are information present under SOAP service. So the format for SOAP is XML. Again, if the request is XML, XML is the response. Transport is SOAP over MQ, or the message queue, or the HTTP. And the service definition is WSDL. You might ask, what is WSDL? And the operation and messages are described through the WSDL. That includes the endpoint, the operation, the request structure, and response structure. So now WSDL are files. And they are XML files with tags to describe an interface offered by a web service. So I think that is already clear. REST, on the other hand, was a term coined by Roy Fielding, the creator of the HTTP. Of course, he has to make sure that the best use of HTTP is prioritized. So such methods are utilized, and that is very practical as well. So, yep. Okay, now let's move on. So again, if the request is JSON request, of course, the response would be JSON as well. So here are key abstraction. When we talk about resource or endpoints, it has a URI, or uniform resource identifier. A resource can have different representation, such as XML, HTML, JSON, for example, and then we utilize all or everything that HTTP has to offer. That is for JSON. Now, for example, we wanted to create a user, of course, post, and then we have the /users, which points out to all the users. We get into the endpoint where we want to create users, and we simply bring it there. We could delete a user, and we want to delete a user, and we have to bring it to /users and then 1, because that is where we would like the endpoint be. And get all the users, then we use the get function, or the get method, sorry, and then / the user, just like in creating a user. Or get one user, therefore it's get and then /users /1. Now for REST, data exchange format has no restriction because JSON is popular, and transport only HTTP or HTTPS nowadays. And it uses no standard for service definition, but there are familiar and popular one which are called WADL or this or Swagger. Okay, now REST versus SOAP. I just saw that REST and SOAP are always compared, so I included this. So there are restriction over the versus architectural approach. So a REST is more like an architectural approach, where SOAP is just restricted to what the SOAP environment entails. The data exchange format, the service definition, transport, and ease of implementation. And the JSON is now, I would say, yeah, it's relevant to use and follow and use JSON as a format into writing and providing web or information endpoints over the web. Now, the concept discovery at the time of the writing is likely to become more important. So it says there at the time of writing, but it is now. So it says it's dynamically locating a service required by a program via some remote registry of a service and dynamically identifying the number and type of arguments needed by that service. At the time of writing, the discovery is not widely used. So, yep. Now, examples of web services is an example of an eBay auction analysis. So this is an auction monitor use case where the auction site and the bidder gets the bid data and the calculate the bid price depends on the get bid data, just like what I'm saying. If you're very familiar with the NFTs today over the decentralized network or the blockchain, if you created an NFT and say you put it into an auction, while you dictate the price of your painting or your specific NFTs, the price would depend on consumer behavior or the demand over how many people really understood the beauty of what you're doing. For example, nag-video ka ng sarili mo and then you made it an NFT and you put it into an auction over the decentralized network or the Web3. Di ba po, nowadays we install MetaMask as a Chrome browser extension, and then we could already integrate and get access to decentralized applications like the games, Axie Infinity, ano ba yung mga popular ones, and all other games which are thought to have value over consumer behavior. So the more people understood the value of that, therefore that pertains to the price. So, well, anyway, this one is an old representation of the same idea I'm talking about, and this is the class diagram for that. So this one shows a possible design structure of the system. So the eBay data looks up module and responsible for the get bid data use case. Now, it passes a list of search string as input and assembles a URL. So it assembles a URL upon the search string that was price and maximum price of the item that they are actually bidding. So this one shows classes and association between auction and the bid item. This one is okay. It's the same thing. It's just it explains the UI of what the user sees over the monitor and the layer of the functional core where the bid estimates is calculated, and the data management is over below where the HTML filter, just like what I said earlier, and then be processed over the system. So it creates a lookup, and then it compares prices, how many people are bidding, what is the best bid price, how much people are asking for a price, and then prints out response based on their requests. Okay, another example is the internet jukebox. So this one is an old, not entirely old, but extremely relevant until today, because we are all but creating content. People are now, I would say, the currency nowadays is attention, where if people could you could create an item or present it to the public, and people would hold um, attention to that. Streaming together with advertising and all other uh, industry money-making system are all part of this attention currency. That is where the money goes. Like for example, in Netflix, if there is a new and a new movie that is somehow um, expected to blow, the same concept of internet jukebox implements the same streaming of multimedia uh, uh, elements. So yeah, it could be audio files. Not today, it could be video. And here is a component of the same. I mean, what we are doing right now. But before, when it was the jukebox components, it's as simple as the computer one and computer two, where if it's streaming, there is a data provider where there is a request to play a track or a playlist, which is initiated by the remote control. And the result of the media is, of course, requested and then stream it back to the streaming server. So the streaming server is separate to the one who keeps, and let's say the FTP uh, translate back the request. Okay, now the web service design guidelines are the following. So it necessarily involves access to remote data. It represents a common subtask. It does not require fine-grained interchange data, and it is not performance critical. Well, not entirely, because it is already clear when machine to machine are interacting with one another. The endpoints are clear, the data is clear, the documentation are clear. So it is important to use, of course, web service in an inappropriate way and for tasks for which they are suitable in terms of a solution. Okay, so I guess I would not add any more to that. And this is a sample diagram of an implementation of web services using J2EE. So this one provides an API or JAX RPC for programming. This one's using XML as base protocol. And of course, it's XML, therefore it's SOAP format or SOAP message format. And it's very similar to the Java RMI or the remote method invocation. Now, going back to the service endpoint, it must have the following properties. One, it should extend the Java RMI or the remote interface. This is at the time of writing an implementation of the Java. It should not define constants. This will be unusable by clients because their symbolic names are local to the server computer, and because it has to be flexible. Each service method should include Java RMI or remote exception in its declared exceptions. And this one, method parameters and return type should be supported, of course, by specific or JAX RPC type, or for example, primitive types, wrapper classes for primitive types, string classes. So compatibility would always be, of course, a priority in setting up method parameters. Okay, so I guess that ends my report. I hope you learned something with web services, and it is an exciting area. And these are my resources. So we have described some of the technologies application of web services that include some of the frameworks of such development systems. Thank you so much, po.
Okay, I'm sorry, I have an emergency call actually, no? Now, congratulations now to the presenter. It's very comprehensive, no?
Thank you, sir.
Because actually, no, this topic is covered with I think 2 semesters, no? So, because as what I've mentioned earlier, no, a web service is a network-based way of communication between 2 electronic devices, I mentioned, right? So, because of different software uses different programming languages, there is need for a data exchange technique that is not dependent on a certain programming language, no? So, a while ago, our presenter mentioned about XML, JSON, and as the result, web services can communicate data using XML files. So, it is also necessary to define communication rules for many systems, such as how may one system request data from another, which precise parameters in the data request are required, what would the data structure look like, no? And to make troubleshooting easier, devise what error messages to display when communication rule is broken. A while ago, our presenter gave us a lot of examples in the explanation about WSDL, that is Web Services Description Language. That is a file, no? Actually, that is the extension name is .WSDL, no? Contains all of these communication rules. So, again, proposals aims to create more flexible web services that aren't bound by stringent constraint, no? For each sort of data, a directory called UDDI, or the Universal Description, Discovery, and Integration, no, specify which software system should be addressed. So if a software system requires a specific report or data, it would go to the UDDI to see which other system it may contract to obtain that data. So once the software system has determined which other system it should contact, it will do so using a protocol known as Simple Object Access Protocol, or the SOAP, no? Hindi siya yung safeguard, no? That is Simple Object Access Protocol. And the data request would be validated by the service provider system using the WSDL, or a file, of course. And then the request would be processed and the data sent using the SOAP protocol. Another thing that we need to consider, of course, is the regression testing of web services. So, WSDL parsing is used for functional and non-functional testing of web services, because regression testing is carried out by identifying the upgrades that has been made to the software. Therefore, changes in the WSDL, changes in the code, and selective retesting or of operation are all example of regression testing requirements for web services. So, difference WSDL, unit WSDL, and reduced WSDL are 3 intermediary forms of subset WSDL that can be used to meet the above 3 requirements. And these 3 subsets of WSDL are then concatenated to generate the combined WSDL. Okay? Which is subsequently used to test the web service for regression. So, by completing the selection of relevant test cases to generate a smaller test suite from the existing test suite, no, this will aid automated web service change management. Because several test automation tools such as SOAP, no, yung SOAP kanina, UI, Oracle application, yung sinabi ng ating presenter kanina, no, unified functional testing, Selenium, and others can be used to automate web service testing. But of course, in every application, there is criticism. So, non-RESTful web services are frequently criticized for being overly complex and relying on major software vendors or integrators rather than standard open source implementation. So, when it comes to web service management or web service change management, it works evolving the recording and visualization of changes to a web service, because change visualization and calculation can be done using intermediate artifacts because the knowledge of how to compute change impact is useful in testing. And the top-down development in regression testing reductions is a tool for identifying subset operations in a WSDL file and generating a subset WSD file. Very interesting topic actually. Na? So thank you. I think that's it for the topic.